Okay. Assalamualaikum warahmatullahi taala wabarakatuh. How are you, everybody? Okay. All right. Okay, today we're going to continue with the matrices. We will go through, what we have done on the previous class. I think. Okay, I'll show you the notes. We were here. We stopped at the transpose of a matrix. Before that, we were doing basic concept of the matrices. So that we have done. Okay, let's go through this thing here. Now this is the general form. I have done that. We have seen row matrix. Recording sudah buat, tunggu ya. Can you hear me? Volume, okay. All right. So semua okay dah. All right. So we have done column matrix, row matrix, zero matrix. Okay, so we have a zero matrix, just like a number 0. Okay, this is where we stop transpose of a matrix. Okay, all right. So that's where we stop transpose. There is another one, another type of matrix. It's not in the slide. It's called what do you call it? Identity matrix. Identity matrix. We label it as. Okay, we label it as I. So another one, identity matrix. The identity matrix. We call it I. The I, number 1, it should be a square matrix. It must be n by n. All right, it's a square matrix. This is like a number 1. Okay, like a number 1. So I start with I, say 2 by 2. So that will be equal to 1, 0, 0, 1. So that is I. And then we can also have a 3 by 3. 1, I'm sorry. 1 0 0 0 1 0 0 0 1. And then you can also have 4 by 4. So if you have n by n, you can also construct it identity matrix. Now, what is an identity matrix? Number one, I said square matrix. Here is 3 by 3. Now, number two, the special character that doesn't exist at any type of matrix is that the elements are in the primary diagonal. So we call this diagonal. Okay, diagonal. And the one that goes from left to right, you call it primary diagonal. Because there is another diagonal going that way. Okay, that is secondary diagonal. So you see here the number of the elements in the primary diagonal are consisting of what? Consisting of number 1. So the elements are all 1 in the primary diagonal. So you go here, 1. And other elements, so primary diagonal, the elements are all 1s. No other value. And other elements, 0. So that's identity matrix. So identity matrix is like number 1. Okay, if you multiply 1 with another number, say k, then you multiply k with 1. What do you have? You have k. So that identity matrix is like you multiply I with matrix A. That will be equal to what? That will be equal to A multiplied by the identity matrix. That is equal to A. So it's like a number 1. Okay, all right. So what you're going to do next? We want to do some operation of matrices. Matrix consists of numbers, so we can do operation. So first operation is addition and subtraction. So you have a matrix that you can add. So how do you add matrices? You can add matrices, 2 or more matrices. It can be two or more, you know. If they have the same number of rows and same number of columns. And then you add by adding the elements of the corresponding row and the corresponding columns. Or in other words, in short, adding their corresponding entries or corresponding elements. Okay, so first, same number of row, same number of columns. That means they must be they must have the same size. Okay, and then you add the corresponding elements. So quite simple. Now, if you look at the general form of a matrix, you have here m by n. Okay, m by n. What do? You add elements Aij with what? With Bij. So column J, row I, you add, you will get the corresponding element of the same row, same column. So you add Aij and Bij, what do I get? You get Cij. So you add corresponding element. Okay, any question? So for example, you have A11, you must add to the element corresponding to that the matrix. The other matrix, the element must be of corresponding row and column. So B11, you add to what? You add to A11. I'm sorry. Kita setengah tambah. A11 add to B11. So you got C11 here. Similarly, you have A12, you add to B12. What I get? I get C12. Kita tulis pula C1, A and B. So you can write here A1 plus B1 is equal to what? Is equal to C11. like what stated here. And then so on. You have to multiply all, okay, all the elements for no, multiply. You have to add the elements, all the elements in the matrices. Okay. So what you got will be the sum matrix. We call it C. All right. Okay. Any question? So given that principle, we look at an example. Okay, so I think I got to go open up a new one. No, this is already. Okay, so you have this principle. I have Aij plus Bij equal to Cij. Example, if you look at the two general form, you have A11 plus B11 equal to C11. So that matrix C, okay, that matrix C, you can continue. That will be equal to C11, C12 up to C1n. And you can continue C21 up to C2n. And that will be CM1, M1, all the way to CMN. So you got M by N matrix. Okay, so what I've done here, I equate this thing here, A11 plus B11, that is what? That is C11. So you just add corresponding elements. So come up with this here, and of course you can call it C. Correct? So I just add another, the final form, right? The final form, which is in terms of C. Okay, all right. Now let's look at a few examples, if they have. Kita tengok dulu. Example. Example. So, apa pula ni? So, dia tadi example. Apa? Bagi example. So, example, you go to the book. As long as A and B are of the same size, let's say A is equal to 1, 2, 3, 4, 0, negative 5. Okay, and then you have a B equal to 6, negative 3, negative 5. And then 0, 1, 1. So you see here, first thing of equal sign. Okay, tengok balik. Tiba-tiba disambung. Okay, they are the same size. So here you see here you have a 2 by 3 and 2 by 3. So same size. Same size, then we can add. So you have A plus B, all right, equal to what? Equal to 1. Berapa kali dah ni? Sekali on, sekali it stop. Dia rata balik. Unstable. You know, in the morning, sometimes, you know, internet is heavy. So that is why I sometimes have this problem. So you have a 0, no, 4, 0, negative 5. And then you add to B, which is what? 6, negative 3, negative 5, 0, 1, 1. So what do we get? Okay, got it. So you finish that up. Agak-agak kali ni betul lah ni. Jadi so apa kena buat ni?
Okay, you know presenting.
Okay, you add up the corresponding element, and then you get the start. Okay, the start matrix. Excuse me. The sum matrix. So you add corresponding elements. So what do we have? You have what? Check balik. Okay. So equals what? So you have 1 plus, you got 1 plus 6, and that is equal to 7. So I just write here 7. And then you have the corresponding element here, 2 and negative 3. So you got 2 minus 3. All right. So 2 minus 3 is what? Negative 1.
Answer.
Ah,
I couldn't see your slide.
Yelah. Sebab saya punya internet ni,
Mm-mm.
kejap ada, kejap tak ada, kejap ada, kejap tak ada. So saya kena buat screen balik semula, buat share balik.
Okay, sir.
So kalau hilang nanti beritahu jangan diam
Oh, boleh, sir.
Kalau saya terlupa nak buat adjustment. Tak tahu step. Jaga jadi macam ni. Sekarang nampak screen kan?
Yes, sir. Yes, sir.
No. So you now next you add the next corresponding element, row 1, column 3, with row 1, column 3. So 3 minus 5, 3 plus negative 5. So you got what? You got negative 2. So for addition, kita buat direct ya. You do it right away. 4 plus 0 will be 4, 0 plus 1 will be 1, negative 5 plus 1 will be negative 4. Okay. All right. So that would be the addition of matrices. So you got A plus B. So we look at the rule of addition. All right. Now, if you have A plus B, and that is equal to B plus A. Okay, A plus B equal to B plus A. In other words, if you add A to B, that will be equal to add B to A. So this is called the commutative law of addition. All right. So that is one example. And here, using the negative, you can define the difference of A minus B by the same order. So subtract corresponding elements. Now what we are to look at next is the subtraction of a matrix. So subtraction, we have the same principle. We subtract corresponding element. Okay, so you do the same thing. We have the subtraction. You have what? We have A minus B. So A minus B, that is subtraction. Same principle. Number one, both have what? Same size. Example, if A is 3 by 3, then B should also be 3 by 3. And number two, we subtract corresponding elements. Subtract corresponding elements. Example, If A11, you subtract B11. Right? So if I consider a full example of a matrix, let's say we have A equal to 1, 2, 1, 0, 0, 4, 5, negative 6, 3, and then I have a matrix B that is equal to 2, 2, 0, 0, 0, banyak nggak 0? Zero banyak nggak apa benda? 1, negative 5. And then here I have 3, 2, 1. So you subtract. First thing is you look at the size. So here you got 3 by 3, 3 by 3. Senang, eh? So we can subtract. So how do you subtract? Subtract matter addition. Subtract corresponding elements. So you have A minus B equal to. Okay, now write down the full matrix. Okay, I don't write down here because I okay, write down, and then you subtract corresponding elements, you will get the difference matrix. Okay, so you get will be somewhere A minus B equal C. That C is Cij equal to Aij minus Bij. Okay, okay, finish up. Can you finish up that way? Then tell me what do you get? Okay, got it? Okay, good. So that is subtraction matrix. Okay, so tengok balik. That part 3.1 tu apa lagi ada? Dah biasa kan itu je. You have addition, subtraction, scalar multiplication. Now, what do you mean by scalar multiplication? Scalar multiplication is what? You multiply the matrix A with a constant. Constant, you call it C, or sometimes people write K. So, whatever your notation is, you just multiply it with a matrix A. No, with a constant. Right? So, how do you do that? Then, what we do is this. The principle is you multiply that constant with the matrix. So if the constant is 5 multiplied by the matrix A, then you multiply the 5, the constant, with each element of the matrix. So for example, 5A, then what? A is equal to this thing here, all right? Then what you do is this 5 multiplied by A. Okay, so 5 multiplied by A. You multiply 5 with the corresponding elements, with all the elements, not corresponding with all the elements, then you get the matrix. Okay, so for scalar matrix multiplication, it doesn't matter the size of the matrix. Okay, so scalar multiplication dalam buku kita, they use K, they use C, they use C. 3.2. Or 3.1. the addition, the scalar, they use C. Okay, so you multiply by a C is constant, multiplied by A. So here, A can be any size, n by n. So you can have A 2 by 2, 2 by 1, or whatever, and C is constant. Right. So example, let's say C is equal to 7, and A is a matrix. I just write down directly the matrix, say negative 2, 1, 4, 0, negative 6, 1. Okay, so you have a 2 by 3 multiplied by 7. So you multiply 7 with each of the elements. So what do I have? I have 7 times negative 2. So that is 14. And then 7, 28. And then you got 0, 7 times negative 6. 6 times 6, negative 42. And then 7. Okay, so you multiply the constant. Okay, simply multiply C with each element. All right, and you will result with the corresponding element. Example, C A11. That what you will get will be what? Will be B11. Okay, so that will become the resulting element of the matrix will be from the corresponding element of the original matrix. So the constant will just follow the element of that matrix. Okay, all right. Now subtraction, same thing. Subtraction, okay, you got A minus B. So A minus B, buat lah, kita dah buat tadi kan. Now, you can also, okay, A minus B is not equal to B minus A. Okay, so here, sama juga in number system. If you have 2 minus 1, will not be equal to 1 minus 2. Okay, so the rule is, the rule will follow. Okay, all right. Now, any question? So we are done with 3.1. Tengok buku dulu. 3.1. I will give you some questions, 3.1. 3.1. Okay. Basic questions, just definition, basic concept. Do 1 to 14. You can just answer verbally, okay? You talk to yourself because they kata what is the order of matrix A. So cakap je lah, tak payah tulis, tak apa dah. Okay, cakap je. Okay, now you can do some exercise for addition. So addition, you can do 15, 16, then 20, you have a transpose, and then you got 21, and then you have 24, up to 27. All right, so that is basically addition, subtraction, and what do you call it? Scalar multiplication. Okay, all right. Now we go to 3.2. 3.2 is multiplication. Multiplication is not so straightforward. So let me show you the rule. Okay, a rule of matrix multiplication. Okay, multiplication of matrices. How to multiply two matrices. Okay, this is how you multiply matrices. Or I think we should show you the first concept first. All right. Now, the basic idea of multiplication of matrices is by doing the row matrix. Okay, a row matrix, you multiply with the column matrix, and both have same element. All right, both have same element. So, for example, here I have A is the row A1, A2 up to AN, and then B matrix is the column matrix B1 up to Bn, and they have same elements. I think the notification notation ni sometimes can be confusing. So kita buat macam ni. If you look at a row matrix, let's say A row matrix. So row matrix meaning 1 by n. Okay, just one row. The way to write it, rather than A1 macam tu, we write it A1 1, A1 2, up to A1 n. So that it indicates the row lah. Example, they don't put the row because there is only one row, right? So I don't want to do that because the order that you write matrices is the element A, I, J. Okay, and then suddenly for the column matrix, you don't have the row, you have just the column. So for the row matrix will be what? Will be n by 1, because they say you must have the same number of elements, same number of elements. Same number of elements. So you got B and 1, and that will be equal to what? It will go to A11, A21, up to AN1. So you got one column. So this is 1 by n by 1. All right. Okay, this is the rule of multiplication. When you multiply, okay, when you multiply, the rule is senang. You multiply A 1 by n, you multiply with B n by 1. So you must have the number of columns first matrix equal to the number of row second matrix. So that's why you multiply row and column matrix. Okay, because you will have, you have the number of column in the, the row and the column matrix that you have here, they have the same elements. So that the number of columns in A is equal to the number of rows in B. And you multiply that, that will be equal to C, 1, 1. So the corresponding matrix, all right, the corresponding matrix would be consisting of what? The size should be what? Should be the number of row A, and the column is the number of column B. Okay, so if you have a row matrix multiplied to a column matrix, then your product matrix will be C11. So there will be one row, one column. So there will be just a number. Okay, so you call that matrix just one row, one column, but sama macam number. Okay, all right. So that's what you get when you multiply row and column matrix. But first thing, if you do this, they have the same elements. Okay, same number of elements. In other words, the number of column of A, okay, number of columns, first matrix must equal number of rows of what? Of B. So you get here. If we're here, if we have something like this, B, let's say A, 1, N. And then the other matrix is B, M, 1. This one you cannot multiply. Why? Because they will not be consisting of the same elements. N is not equal to M. All right. But that is a general rule, though. So that is a general rule of a matrix. So if you have a bigger matrix, then A, 3 by 3, you can multiply to a matrix 3 by 4. Why? Because here columns and row same. Okay, you can multiply. Then will be equal to C. The product matrix will be 3 by 4. Okay, right. But here, let's do the row and the column multiplication, because that will be the basis of multiplication. So how do you multiply? How do you do multiply? If you look at the notes, senang. How do you multiply? You multiply corresponding elements. All right. You multiply corresponding elements and then add them up. I will use mine. I going to say that because I put the number of row and column. In the textbook. So sometimes, it can be confused. So what you do here is multiply each element. So I will continue from here. All right, equal to. So you write down, see. All right, A equal to, you write down, you tulis tahu, A and 1 by N. Space ada. A 1 by N multiply with B N by 1. Oh, tak payah sebut, tak apa. Boleh mention sebab kita dah tahu. Same size. So A, B. Okay. And that will be equal to benda ni lah. Ini lain ni tau. Ini lain. Okay. You can write down. So A, B. So you put like in the notes. A dulu. And then B. Okay. Now, how do you multiply that? Okay, how do you multiply? You multiply corresponding elements. You multiply corresponding elements and then add up. So it will be equal to what? It will be equal to A11. B pun saya bagi A. Itu tak betul. Ini silap ni. Sepatutnya jadi B lah, tak kat A pula. Kalau A macam penat kita, A di matrix A boleh juga. Tak ada hal boleh juga. Tapi nya benda sama lah. Okay, so you put A, B11. So A11, you multiply to B11 plus A12, B21. So on. Plus, A1N, BN1. BN1. You add out. So when you add, what do I get? I get C1, 1. Okay, I get 1, 1. So that will be just one number. So in other words, if you look at matrix, so matrix is 1 by 1. Okay, all right. Any question? Okay, example. Tengok example, ada bagi tak dalam ni. Kita tengok example. Oh, dia tak bagi. So tak apa, kita buat example. So example, if I have A equal to 1, 2, 4, -3. All right, and then B is our column matrix. So here I have 1 by 4. So the column matrix that we can multiply with A should be what? Should be 4 by 1. So column is 4. So you got 0, -2, 3, 5. So you see here, 1 row, 4 column. Okay, and here I have 4 rows, 1 column. So you can multiply because the number of columns here equal number of row. So equal. So boleh multiply. All right. So how do you multiply? AB equal to 1, 2, 4, -3. All right. Multiply with, you write down like this: 0, -2, 3, 5. Okay. So what is it equal to? So you multiply corresponding element, add them up. So 1 times 0 plus 2 times -2 plus 4 times 3. Okay, and then plus again, -3 times 5 equal to, that will be equal to the value. Okay, any question? All right, so I give you another example. Okay, do one more example. Okay, you look at 13.2. No, I'm sorry, 3.2. 3.2, you do question number 2A. Buat question 2A. That is the principle of multiplication. Okay, first person who finish it, let me know, so that we will continue. Okay, all right, good. Now that is the principle. Okay, that is the principle. That means for the general matrix, you apply that basic principle of multiplication. Now, if you look at a general matrix, how do you multiply? Okay, if I have 2 matrices like this, so you have what? You have matrix A. All right, matrix A, size m by n. And then you have a matrix B, n by p. Okay, so you want to multiply AB. Okay, now if you multiply AB, first thing that you check is that what? The columns of A must equal row of B. So here I have n, same thing. So therefore, we can multiply. And the product matrix, you call it C, the size will be equal to what? The size will be equal to M, the number of row of A, and P, the number of columns of B. So you got a matrix C size what? M by P. That is multiplication. All right. Okay. So to multiply, we use the principle of row column multiplication. Okay. All right. Example. You have M by N, A. And then you have B, N by P. Okay. Don't worry about the size of the matrix. We just multiply by the rule. Okay. This is general. We are not going to do anything like this. So how do you multiply? Okay. This is how you multiply. First, you look at the first row of A. All right. First row of A. And then you have to multiply first row of A to the first column of B. Okay, done. Okay, good. And then that first row of A, you multiply by what? By the second column of B. And you continue until what? Until the last column of B. Okay, so that's how we do multiplication. So we do it here. First, okay, you got A times B lah. A, M by N. And then you got B, N by P. So our C will be what? M by P. So that is the basic rule. Number two, you multiply. How do you multiply? You start with the first row. First row of A. You multiply, okay, multiply to each column of B. Multiply in order, okay, multiply in order. Okay, first row, first column, first row, second column, so on. And then number three, you go to the second row of A. What do I do to the second row of A? You continue the process again. Multiply to each column of B. And number four, okay, number four, what do you do? The third row of A. What do I do? Multiply with each column of B. And we continue until what? Until the last row, okay, the M row. That means last row, okay, the last row of A. You continue with that process. So what is the principle? Principle is every row of A, you have to multiply with what? Multiply 2 or with to each column of B. Okay? So what we have done, every row of A, you multiply with each column of B. Now that will complete the multiplication. And how do you multiply? We use the principle row matrix multiplied by column matrix. Okay? All right. So if we do that, okay, if we do that, we go back to the notes. Okay, in general, if I multiply row I, okay, row I of A, and then I multiply with the B as matrix, the row J. Okay, so you got A1, AI1, and then B1J, B2J, up to B and J. So you multiply, but what do I get? I get Cij. Okay, so that is the principle of multiplication. To see it better, kita tengok example. Kan benda ni general, kadang susah nak tengok, dia besar kan. So kita buat example. Kita buat matrix ni. Alright, so example. Okay, before I proceed, any question on the multiplication? Okay, okay. Kalau ada question, tengok example dulu. So let's say A is equal to 2, 1, 4, 0, negative 3, 5. So here I have a 2 by 3. 2 by 3. Now, if you want to find the matrix B that you can multiply to A, okay, let's say you have here 2, negative 4, 5, 1. So here I got 2 by 2. First thing, can you multiply? Before you multiply, tengok dulu, boleh multiply ke tak? Boleh multiply ke tak boleh ni? Tak boleh. You know why? Because the column here is not equal to number of row of the second matrix. So you see here, not equal. So you don't try to be smart to multiply, all right? Because at the end, we are not smart. That row, that thing cannot be multiplied. Okay, all right. So in order for you to be able to multiply, you must have that matrix B should be what? Should be made of 3 rows. So kita buatlah row lagi satu, baru boleh multiply. Okay. So tambah lagi satu row. Tambah lagi satu row. 0, 3. Kita tambah kolom buat apa? 2, 6, 1. So here I have a 3 by 3. Okay, 3 by 3. You see here, can we multiply or we cannot multiply? Boleh multiply. The row second matrix equal to the column first matrix. Equal. So good, multiply. And then what you will get will be what? C. What is the size of the C? 2 by 3. So kita mesti dapat 2 by 3 lah. Kalau multiply dapat. Okay. So, if you multiply, you got 3 by 4. Apa belakang? Salah. Okay. So 2 by 3. And the principle of multiplication, we apply the row column principle. So AB is equal to. Now you have to write the matrix. Okay, jangan malas. Boleh. Negative 3, 5. Okay, and then you multiply with the second matrix. 2, negative 4, 2. 5, 1, 6, 0, 3, 1. Okay, all right. First, what is the principle? Every row multiplied to each column. Betul kita ni? Every row multiplied to each column. Betul ke tak betul? Cuba cek balik. Betul ke tak betul saya buat? 2 by 3. Ini bukan 2 by 3. Ini berapa ni? What is the size of matrix A? Apa saya tak beritahu ni? Kepala pun. Matrix A, what is the size? So saya salah atau tahu?
3 by 2.
3 by 2 apa saya diam je. Ada 50 orang dalam kelas. Seorang pun tak cakap. Apalah. Cakap lah. Ni saya dah sampai ke situ dah. Ni kalau ajaran sesat ni masuk neraka semua. Ikut saya. Lain kali kalau nampak silap, cakap lah. Ni main diam je semua. Okay? When you talk the right thing, very good. Okay? Yang saya tak suka, kalau cakap, dia kagut. Okay? Kalau cakap the right thing, you make a correction, then that's the right thing. Okay? I don't have to waste my time. Boom, sampai sini tak boleh. Why? Because I make a mistake now. Ni 2 by 3. Ni apa ni? 3 by 2. No, 2 by 3. Okay? So next time, if your teacher, not necessarily mean lah, if your teacher ke siapa buat silap, cakap cepat. Okay? We are not going to be mad. Actually, we are happy. Okay? Cikgu ni, kalau dia buat silap, anak murid tegur, happy. Okay? Bukan je nak marah. Happy lah. Because you do mistake, your students make the correction. Okay? That's good. So lain kali kalau saya buat silap, bagi tahu cepat. Jangan tunggu sampai nak kiamat baru nak cakap. So ini berapa ni? Ini berapa? Sudah. Saya pada lupa dah. Ini berapa? Ini 3 by 2 kan? 3 row, 2 columns. Tadi the theory was correct. Okay, the theory was correct. But the matrix salah. Sebab row dengan kolom terbalik kot. Saya harap kamu semua kalau yang tak apa pandai tu pening tak apa lah. Okay, biar pening tak apa, jangan tak pening. To be confused, okay, this is the principle of learning. To be confused when you learn, okay, to be confused is better than it's good, you know. It's better than not understanding at all. Not understanding at all. If you don't understand at all, then you feel nothing because you don't understand. But if you don't really understand, you understand partially, okay, then you may be confused. That's good, okay, because by the confusion, that means you know something already. Then you have to untie the confusion, okay? Then you have to untie the confusion. So to be confused is good. Don't say that I'm confused and that's bad. No, if you're confused, that's good. But you have to do further learning. Okay, some people, they're confused, they stop. So if you're confused, don't stop. Okay, continue to be unconfused. Of course, you know, for average students, but for some people who are very, very good, very smart people, you know, they understand right away and not confused at all. That's good because that is another class of students, you know. But for us, most of us, we are what? We are average students, you know. So average student, kita kena what? Kita sometimes confused dulu. Kita baru paham. So ini dimension sudah silap. So here I have also to make the adjustment to make that matrix the size should be right. So here I have what? 3 by 2, 2 by 3. So now baru betul. Okay. Tadi semua betul tau. Yang saya kata ni betul. Tapi jangan tengok matrik dia. Matrik salah. Okay. So you will have multiplication of this matrix. So you see here the number of column first matrix, column rows second matrix equal. So multiply. All right. And I write down here, you got A 3 by 2, B 2 by 3. So what is the size of the product matrix? It will be C 3 by 3. Okay. Ini sama. So size will be 3 and 3. All right. Okay, good. So now, how do you multiply? Multiply macam tadi lah. The principle, you multiply first row with each of the column. And then you multiply the second row with each of the column. All right. So you will get here 3 by 3. Now what I will do, I don't want to put in one matrix. Okay, what you do, we multiply each row dengan every row tu dengan each column. Kita buat multiply using the row column multiplication. So here for the first one, first row, okay, row number 1, you multiply, you got 2 1. Multiply to what? column 1. Okay, column 1 of the other matrix. 2, 5. Okay, so in other words, what I'm doing, I multiply first row with first column, and then second column, third column. So I do it here. So what is it equal to? You got 2 times 2 plus what? 1 times 5, that is equal to 9. So that will be equal to C11. Okay, so C11, C, yeah? C11. Tahu 9. Correct? Then you do the second multiplication. The second multiplication, what do you multiply that with? We multiply row 1, then we complete the first row. So row 1, 2, 1. Okay, that is row 1. You multiply to the second column. Tadi first column, 4, 1. C2, column 2. So what do you get? Dapat berapa? Kita akan dapat 2 times -4, that is -8. Plus 1 times 1, -1. So that is the -9. So -9, row 1, column 2. Row 1, column 2. So what do I get? I get -9. Okay, bukan -9. Okay, apa tu? Lepas tu, kita multiply, we multiply the first row with the third column. Okay, you multiply first row, third column. So row number 1, you got 2, 1, multiply 2, 2, 1. That is column 3. What is it? You got 4 plus 1 equal 5. So that go to what? Row 1, column 3. So row 1, column 3, 5. Okay. So after that, you look at the second row. Repeat the process. Okay? Okay, finish up. All right, I do the first row, you get finish it up. Okay, finish it up. Okay, anybody has a problem with this multiplication? Addition, subtraction, kacang. Okay, this one not so kacang. Kita kena multiply, lepas tu kena add. Okay, finish it up. You got it?
Yes, sir.
Okay, good. So if I want to do it, that will take a lot of multiplication. So I hope everybody, when you do understand that principle, just check multiplication lah. The only mistake that we may do is sometimes, when you add 2, sometimes maybe silap. So after you do the multiplication, the addition, just check whether it's correct or not. Okay, good. Now, what you want to do next is that we are going to move on. We're going to look at the kita nak tengok dulu. We want to find next is the inverse of a matrix and the determinant of a matrix. But I want to find my next. Okay, determinant, very, how do you get the determinant of a matrix? Determinant of matrix. Okay, I start with A, 3 by 3. Okay, how do you get the determinant? Now, determinant, we denote by the following notation. Absolute value. Okay, the sign is absolute value A, and determinant is only for square matrix. So you can get A 3 by 3. All right, or you can do it for 2 by 2, 4 by 4, etc. Must be what? Must be square matrix. All right. Now, if you look at 3 by 3. 3 by 3, because to get determinant is easy. Okay, I have a 3 by 3. Let's say it's 3 by 3. I have here A11, A12, A13, A21, A22, A23, A31, A32, A33. That's matrix A, 3 by 3. Now, how do you get the determinant? Determinant, that is the notation, and what you determinant is a number, okay, just a number, single number. So what do I do in order to get that determinant? Now the raw method is this. Method ni raw method, dia tak ada, you just rearrange the numbers. So I put first row sini. And then I put first row, first column. And then second column, I put here. All right. So what you do next is this. You multiply all the elements in the primary diagonal. Add them up. And then you multiply all the elements in the secondary diagonal, subtract. So in that way, you get to get the determinant of A 3 by 3. Okay, so what you will get will be the following. So A determinant will be equal to, you multiply A11, A22, A33. That is 1. Okay, add A12, A23, A31. Add A13, A21, A32. And then minus A12, A12, A21, A33. Minus the others. Okay, but you don't have to remember. Dalam belakang ni, I remember A11, A22, A33. We just follow this rule here. Okay, this rule. You do the multiplication according to the what do you call it? Okay. So let me give you an example. Suppose I have A, all right, equal to 1, 0, negative 2, 4, 2, 3, 5, negative 1, 0. Okay. Now I want you to find A. Guna tadi tu. You multiply the way I put the diagram. Right? Cuba buat. Senang aja. You multiply, you add. And then the other way around, you subtract. Today is 17. Okay, we have 3 more classes, is that right? Betul tak? Kita ada 3 more classes. I just want to confirm. So you for our class, the last class will be the 26th of January. Betul tak? Last class ini kan? Sebab I have not confirmed dengan UAE, dengan kuliah. Betul tak? 26? Last class 26, is that right? Or is the last class 1 week before that 26? Last class 26 ke bukan? 26 kan? End of January.
Supposedly earlier.
Huh?
Supposedly it's earlier.
Earlier? Bila? Berapa hari bulan?
Because this week is already week 15.
Bukan kita 15 week ke kita?
It's 16 weeks.
Bukan 16 week ke?
There are 2 weeks extra for study week.
So when should our semester end?
Suppose this. If last class, suppose Wednesday. This Wednesday.
Ah, biar betul. This Wednesday ke?
Because all classes have already ended last week.
Betul ke ni?
Yes, sir.
Saya tu ingat, because I look at the original calendar tu, class end 26 kan. So kalau macam tu, because our exam will be on the 5th, betul tak? 5th February.
Yes, sir.
Bila your study week bila? Sepatutnya study week bila? Study week next week.
Revision period 29 until 2 February.
Kalau revision 29, so 26 dengan 24 tu ada kelas lagi dah ke?
In calendar, they say it's 29, but actually, Canmas gives 2 weeks duration for study because Canmas classes start earlier than other kuliah.
Oh. Is that right? I will confirm that.
Okay.
So if our semester end, kalau katakan this is the last week, okay, if this is the last week, then because my budget is until the 26th. If this is the last day, I mean this week is the last week, then you know what, I will have to. I will have to, you know, I have to potong benda yang patutnya tu. I will confirm. If our last day of class is 19, your exam start on when? Exam start lambat lagi kan, bukannya 29 kan, 29 is your study period. So maybe I will need 24 lah. You know, anyway, I got 19 dengan 24. I need to have another class on the 24th, all right, to cover these matrices.
Boleh, sir.
If I can finish, if I cannot finish, if I can finish on Wednesday, then tak payahlah. Tapi Wednesday tu susah sikit lah. I got to go fast. Okay, so tak apa. Thank you for the information. Saya do assume 29 lah. That's why I want to confirm with you, you know, because nowadays you do online, you don't check with the department. So I will check with the department and see. So dah siap. Are you done with this? So determinant, you do it like this. Macam saya kata tadi lah. Alright, you put in the first column here, 1, 4, 5, 0, 2, -1. So you multiply each of the elements in the primary diagonal, add. And then the other diagonal, subtract. Okay, betul eh? Boleh? Alright. Now, if it is 2 by 2, I'll finish up with this one. If A is 2 by 2, say A, B, C, D. 2 by 2 senang je kita buat A, B, C, D. The determinant of A is just equal to AD minus BC. So 2 by 2 senang. Alright. Example, if I have A equal to 2, 4, 5, 6, then what is the determinant? Will be 2 times 6 minus 4 times 5. So that will be what? 12 minus 20. That is negative. So that is the determinant of A. Now, determinant, absolute value, but it's not absolute value for numbers. It's just the notation. So, determinant of A, it can be bigger than 0. It can be less than 0. It can be 0. Okay? So, the possible values. All right? Okay, I stop here. I will continue on Monday. If, you know, on Wednesday, if that will be the last hour class, then maybe I cut short. Okay, cut short. And we will see what we can do. All right. If I cannot, then I may need some time on Monday next week. Okay. All right. So I'll see you again. Have a nice time study. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.
So,
Thank you, sir.
right, thank you.